dance, the firefly's luminescence pattern, even with courtship behaviors that are not advantageous to survival. Those individuals that excel in them produce offspring, and it escalates with each generation. The same was true of the vocal cord parasites. Courtship vocalization rhythms and intonations became more sophisticated, and in order for man to produce such sounds, they had to alter his vocal organs by lowering the position of the larynx and developing resonating chambers. They enabled more complex pronunciations, but that was not all. The vocal cord parasites activated a transcription factor that would later control man's language ability. A protein that, due to its appearance, is called forkhead box protein P2, or FOXP2. Activating this transcription factor led to the development of brain function capable of creating sophisticated frequency changes. This was the pinnacle of the vocal cord parasite's prosperity. However, this sophisticated pronunciation control was too useful for man to ignore. Once human sexual activity ceased to be only seasonal, and having lost pigment-based sexual characteristics, distinctive vocalizations became the most effective means for humans to attract mates as well. Combined with logic pathways hardwired into the brain, or universal grammar, it was not long before advanced communication was possible. This was the birth of language. Luckily for man, it was around this time that a retrovirus was circulating. While not lethal, it infected not only man, but the vocal cord parasites as well. It is presumed that this virus removed part of the parasite's DNA and reverse transcribed it into man's reproductive cells. It was a vector. Among the genes it transcribed were the ones responsible for the production of language. The vocal cord parasite's vocalization genes were written into the human genome. The parasites were no longer of any use to man now. Man could use his voice as he pleased when he pleased, hindering the parasite's courtship vocalizations. Having lost their opportunity to reproduce, the parasites died out, leaving behind only the transcribed genes. The vocal cord parasites were once in symbiosis with man. Its genes even became a part of his. Humans and parasites are extremely close. As such, it will be extremely difficult for man's immune system to eliminate the vocal cord parasites. Even cutting them out will be no simple matter, which is exactly why these ethnic cleansing parasites are
He's coming too. Roger that.
The rise of the vocal cord parasites goes back approximately 300 million years to the Permian period. At that time, they were not even parasites, but predatory autotrophs. They are believed to have been the common ancestor to the Pentastemida and the Cyclops genus of copepods. However, Earth's environment underwent a violent change at the end of the Permian period.
You gotta extract him.
This is unclear, but evidence suggests that over 90% of the Earth's organisms at that time died out. The most pronounced threat to the protoparasites was the severe reduction in oxygen concentration. The result was cladogenesis, a splitting that gave birth to a new strain that could parasitize other organisms' respiratory apparatus. This survival tactic helped lower their oxygen consumption, and inhabiting the throat kept them securely in contact with inhaled air. The best survivors were those that parasitized the reptiles that flourished at the time. Entering the Triassic period, the reptiles evolved into dinosaurs, protoparasites shared in their success. Dinosaurs developed respiratory organs called air sacs to adapt to the low oxygen environment. These in particular helped the protoparasites thrive. But another trial awaited them. The end of the Triassic period